Hello everybody, welcome to my campus. Today we'll be talking about completing the square method. So completing the square method is a method that is used in solving quadratic equations. Okay, so what is a quadratic equation? Quadratic equation is an equation which is in the form, hold on, let me get my pen to work, ax squared plus bx plus c equals 0. So this is a standard form of a quadratic equation. This equation is a polynomial. Okay, a polynomial is the sum. So looking at this, ax squared and bx, these are two different terms. Ax squared is one term, bx is another term. Okay, so the combination or the sum of two or more different terms is a polynomial. Okay, the name of the polynomial is derived from the power, the highest power or degree of any term. Okay, so looking at this equation, the highest power is 2. So it is called a quadratic equation. Okay, the highest power or exponent is 2. So that is a quadratic equation. If the highest power were to be 3, then it would be a cubic equation. If the highest power were to be 4, then it would be called a quartic equation. And if it were to be 5, then it is going to be a quintic equation, and so on and so forth. Okay? So what are some of the applications of quadratic equation? For example, if you throw a ball into the atmosphere, at a point in time, the ball will eventually drop. We can model that projectile by quadratic equation. So the quadratic equation can tell us that at what point that the ball is going to reach its maximum height, and then at what point that the ball is going to fall. Okay, so this can translate to athletics, like field events like javelin or shot put. Okay, we can model the throwing of a javelin, okay, by a quadratic equation to tell us the maximum point that that object is going to reach, and then when it's going to fall to the ground. So these are everyday examples of quadratic uh, equations. Okay, the use of quadratic equations. Okay, so now let's talk about completing the square method. Well, for this video is going to be a lengthy one. The essence that I'll be proving why one of the methods that we'll be using. The process is pretty much simple, but this is going to be a lengthy one because I'll be showing you how we derive the third step in completing the square. Okay, hold on, and then let me clean this up, and then let's continue. Okay, so we're going to talk about completing the square method using solving quadratic equations. Okay, all right, step number 1. So we're going to talk about the 3-step process. Step number 1, we need to rewrite the equation such that it is in the form ax squared plus bx is equal to c. That is the first step. Okay, so looking at this equation, okay, it has to be in the form ax squared plus bx, and then c is on the right hand side of the equation. Okay, so it means we need to move the c to the right so that we satisfy step 1. Okay, so this implies we're going to have ax squared plus bx is equal to minus c. Okay? C is positive on the left hand side. So when it moves to the other side of the equation, it becomes negative. Or similarly, we can add negative c to both sides of the equation, and we would yield the same result. Step 2. This a is called the leading coefficient of x squared. What is in front of x squared is called the leading coefficient of x squared. This b is called the coefficient of x. And step 2 says the leading coefficient of x squared must be 1. Okay? In other words, the a, what is in front of x squared, must always be 1. So how do we achieve that? It means we need to divide the equation by a. Okay? So let me finish up this process. This can be rewritten, what I've underlined can be rewritten as ax squared plus bx is equal to c. Okay? Why are we changing minus c to c? Because c is just an arbitrary constant. Okay? It can be anything, it can be any number. It's just an arbitrary constant. So I'm just changing minus c to c. Okay? Because the arbitrary constants. Okay. So the second step says the coefficient of x squared has to be 1. So that implies we have to divide the equation by a. So we're going to have ax squared over a plus b over ax is equal to c over a. Okay? Let's simplify further. This is going to give me the a and the a will cancel out. So I'm going to have x squared plus b over a. Once again, b is a constant, a is a constant. So they are arbitrary constants. So I can replace it with b. Okay? C over a is also what? Arbitrary constant. C and a are both arbitrary constants. So I can equally replace it with what? C. Okay? So step 2, the key thing is we need to divide the equation by a. Okay? We need to divide it by a. Okay? That is the most important thing. Right? I have done the simplification on the left hand side. Okay? But these are the key roots. Alright, let's proceed further. Now, completing the square method. These two terms, x squared plus bx, we need to come up with the difference of two squares. We need to come up with an algebraic expression which is the same as x squared plus bx. Okay? Come up with the difference of two squares which is the same as x squared plus bx. So what is the difference of two squares? A squared, that's a perfect square. Any number raised to the power 2 is a perfect square. B squared, that is also a perfect square. When we find the difference, okay, difference in subtraction, then we are talking about what? Difference of two squares. So we have two squares, a squared and b squared. The difference, okay, so a squared minus b squared is called the difference of two squares. Now, this is the same as a plus b multiplied by a minus b. Okay, we can prove that if a multiplies a, gets a squared. Okay, so we are expanding. A multiplies negative b gets negative ab. B multiplies a, positive ba. B multiplies minus b, minus b squared. Okay, so this is the same as minus ab and positive ba will cancel out. Okay, mind you, ab is the same as ba. Okay, multiplication is commutative. So this is the same as a squared minus b squared. Okay, now what I have underlined on the left, x squared plus bx. We are trying to rewrite this as the difference of two squares. Okay, all right. Now let's consider x plus b all squared. Okay, so this is the same as x plus b multiplied by x plus b. And when we expand this, we're going to have x multiplied by x, which is x squared. X will multiply b, which is bx. b will multiply x, which is bx, and then b will multiply b, which is b squared. Okay, let's simplify further. So this is the same as x squared plus 2bx plus b squared. Okay, now let's compare what we have on the right to what we have on the left. We have this x squared and then this x squared. Okay, so one of the terms has been satisfied. Now we have bx, but we have 2bx. Okay, so this perfect square here, right, has to be what? Modified. It does not suit our needs, so it has to be modified. Now, let's try x plus b over 2. Okay, so using the same analogy, when we expand this, it's going to be the first term squared, which is x squared, plus 2 times the first term, which is x, and then the second term, which is b over 2, and then the second term squared, which is b over 2 all squared. Okay? Now, let's simplify further. This is the same as x squared plus this 2 and this 2 will cancel out. So we're going to get xb or bx, okay, plus b over 2 all squared. The reason why we are using a denominator of 2, okay, the reason why we are using a denominator of 2 is that we know that the middle term, okay, is a product of what? The first term and the second term. Okay, so the middle term is the product, it's 2 times the product of the first term and then the second term. So this 2 and this 2 will cancel out. And then we get bx or xb, which is the same as what we have on the left hand side. So intuitively, that is why we are using a denominator of 2. Because we know that the middle term is 2 times the first term multiplied by what? The second term. So it will cancel out and then we get xb, which mirrors what we have on the left hand side. Okay, so rewriting this, we have our x squared plus our bx, okay, which is the same as x plus b over 2 all squared. Okay, I haven't done anything, I'm only rewriting this. And then we have b over 2 all squared. It's on the right hand side. So when I move it to the left hand side, it's going to become negative b over 2 all squared. Okay, so we can see that we've rewritten x squared plus bx. Okay, now to be the same as what? The difference of 2 squares. Are you with me now? So this is now the difference of 2 squares. X plus b over 2 all squared minus b over 2 all squared is equal to c. Okay, so x squared plus bx has been rewritten to be the difference of 2 squares, where is x plus b over 2 squared minus b over 2 squared. Okay, now let's tidy this up a little bit. So this is the same as x plus k all squared. I'm replacing b over 2 with k minus k squared is equal to c, where k is equal to b over 2. All right, hold on, let me clean this. Okay, all right, so let's clean this up a little bit. So this is the same as x plus k all squared is the same as, this is minus k squared. Okay, when you are calling out a number, very important, look at the sign in front of it. So this is not k, this is minus k squared. Okay, when you're calling out a number or mentioning a number, look at the sign in front of it. So this is minus k squared. It's negative on the left hand side of the equation. So when we move it to the right, it will become positive. Okay, and this is the formula that we'll be using in completing the square method. Okay, so this video is a lengthy one because I wanted to derive the formula so that you can understand. Okay, so that it makes sense. So let me put it down. Number 3, we'll be using the formula x plus k all squared, which is the same as k squared plus c, where k is b over 2, which is the same as 1/2. Okay, so these are the 3 steps that you need to know when using completing the square method. Okay, all right. This video was a lengthy one, but I think it was worthwhile. So we'll be solving more problems in the next video. Okay, see you.